guys, so we are going to get into modules 26 and 28 where we talk about different irrigation methods. So let's just go ahead and get into it. The point of this is to get into like talking about different ways that we water the crops that we plant, but to get to that we need to first talk about groundwater and where our water comes from. So if we look here, most of the water on our planet is salt water. And we had a discussion in class about why the ocean is salty and therefore unusable. And it's because all of the water that hits the continents, all the water that hits the ground, is picking up stuff as it travels, okay? So you have water that's entering into the oceans from rivers that is not 100% H2O. Okay, it's got minerals dissolved in it, it's got pollutants dissolved in it, it's got all kinds of stuff that it's carrying with it. But when it gets out into the ocean, the H2O is what evaporates, and it leaves behind all the salts, all the minerals, everything that it picked up on its way across the land. So over time, the ocean has progressively gotten more and more saltier. And because of that, it's really expensive and time-consuming, and if you drink it, dangerous to pull those salts and minerals and nutrients and things out of the water. So most of the water on our planet is unusable salt water. Of the 2% that is fresh water, most of that is tied up in the glaciers and in the ice, and so we can't really use it, okay? So only about less than 1% of the water on our planet is usable. And water is a renewable resource. However, we have to use it in such a way that we can kind of stretch its use because it is a timely thing, okay? So if we use water, we have to wait for it to do the water cycle to come back to a usable state. So it's not possible to run out of water on the planet, but it is possible to run out of water in an area, okay? So I want to talk about aquifers. Groundwater, obviously, water in the ground. So if you have rain that hits the ground, that hits the soil right here, we experience this a lot in Arkansas because we live in a very porous, like the ground underneath us has lots of empty spaces in it, so it's very porous. So like when water hits the ground, it doesn't just sit on top, okay? It's going to sink down and absorb into the soil. And because of gravity, it's going to continue to sink and absorb and move down until it hits a layer that it can't sink and absorb into, okay? So underground water, or spaces where water can collect underground, are called aquifers, okay? Now, these are very important biologically because this is what sustains tree growth. Okay, so trees have really deep roots that they are reaching down through all of this dry soil into this wet, saturated part down here. Okay. They also help to carve out little habitats down here for things to live in. But we're not really going to get into that in this class. Sorry about it. So if we have an aquifer, or basically it's like an underground puddle, okay, that's sitting on top of solid rock. If we have an aquifer that water can move in and out of, we call that an unconfined aquifer, okay? And honestly, most aquifers that we really kind of use and know about are unconfined. A confined aquifer is one that has rock on all sides, so it's like a hole in the rock that has water inside of it. Okay, so water's not moving in and out of that. It takes centuries for these to form. It takes centuries for these to recharge, okay? So all of our use of aquifers is going to come from these unconfined. So we refer to the beginning of the wet area as the water table, okay? So it's how far down do you have to dig until you start to hit wet, okay? The uppermost level where the water is saturating the soil, okay? And it's into the water table that we dig wells. So we have a lot of wells in Arkansas because we are a very, very wet state. Our water table is very high, so you don't have to dig too far down before you start getting into wet, okay? And as a matter of fact, we are like one of the wetter states in the continental US. So this chart here is showing you anything that is smaller than the average depth. So all of these are places where the water is closer to the surface. That water table is closer to the surface than normal. Okay, so we live in a very wet area. It's very easy to dig wells here, and this particularly is why it is so easy to grow rice in Arkansas, because we have a very, very shallow water table. That shallow is in like it's not very far down, not shallow as in like it's not very big. So it's easy to get to the stuff to water all of the rice, which is a very water hungry crop. And just for funsies, a place where the water that is in an aquifer bubbles up back to the surface is called a spring. So like down in hot springs, that's underground water. That's water in an aquifer that is bubbling up to the surface, okay? Now, water leaves aquifers through springs and through taps and like us digging down and getting at it. Water enters the aquifer through percolation. So it rains on the ground and this puddle has formed, but over time it will soak down and absorb down into the water, into the ground. And it'll keep doing that until it hits the aquifer or it hits the water table, okay? So that's called groundwater recharge. And it typically is a pretty slow process. So one of the issues that we have to deal with of using underground water is we have to make sure that we're not pulling water quicker than it can recharge. Okay, again, it's not a non-renewable resource. We just have to wait for it to cycle back around. So one of the issues that we run into, especially with this recharge, is that humans love to make impermeable surfaces. Okay, so any water that hits this city is not going to go into the groundwater system. It's not going to contribute to recharge. It's just going to sit there and it's going to flood. Okay, so our impermeable surfaces reduce groundwater recharge and they increase the flooding of the area. So like we've had to invent whole new things to deal with the flooding problems that, you know, our impermeable surfaces create. Like that's the whole entire point of a sewer system, is to deal with the fact that water won't go anywhere. It just sits on this. It also increases evaporation, which can cause like these weird things called heat bubbles. We'll talk about that in a later chapter, but basically it's kind of like we're throwing a wrench into things. When do we not? So another issue that we have to deal with the use of groundwater is if we are pulling on the groundwater faster than it's recharging, it can create what's called a cone of depression. So if you imagine like you're in a bathtub and like you fill it up with water and then you pull the plug and it starts to do that like suction-y thing where it'll make a little tornado and it might even make like a slurping noise as it sucks the water out of the tub and down. So if you imagine that, but upside down, okay, because we're sucking water up out of the aquifer, out of the groundwater, quicker than it is naturally percolating, naturally recharging back down in. So you create this kind of upward suction. So not only is that going to create this area of influence around here where like these trees are going to have trouble getting water now and they may dry up and they may even die depending on how long this takes, because they're used to having their roots down here in the top of that water table. And if we have created this dip, this depression in the water table, we are decreasing, you know, their access to the water. So it can cause adjacent areas to dry out. It can also compromise the quality of the water, because if you are sucking the water up right here, you are also going to put kind of a suction on the water that's still kind of just barely in the soil, but still at the top of this water table, okay? So you can cause the water to basically not, as it moves through the soil, it's going to lose a lot of its toxicity, a lot of the pollutants that have dissolved into it, okay, any sort of acidity that it's picked up. And then it's basically like as it moves through the soil, it's kind of getting cleaned. But if we create this upward suction here, it's getting sucked down quicker. And so it's not spending enough time in that soil losing any like pollutants that are absorbed in it. So you can actually pollute your groundwater by pulling too hard on it. So this is a major problem in coastal areas. So We don't have to deal with this kind of stuff here because we live in the center of the continent, but this like too much pulling causes contamination is a really big problem near the coasts because they have to contend with their fresh water table butting up next to the ocean and its water, it's underground water over here. So the term for it over by, the coast is called saltwater intrusion. So again, if you can see it down here, if we're pulling too much on this fresh water and it's not percolating and it's not like, making a nice little circle, we're going to actually start sucking salt water into this area here, and you're going to get salt water in your taps, or you're going to get salt water going out over your fields, and like that's a huge issue. So coolly enough, here in America, we have one of the biggest, if not the biggest, aquifer on Earth, which is really neat. It is over in the Midwestern area, and it is called the Ogallala Aquifer. Okay, so we need to know that it's over underneath the entirety of the Midwest, and it is rapidly being depleted. So there's a pretty good chance that if we don't do anything about it, the Ogallala Aquifer will run out within your lifetime. And this is a weird, like, kind of sociology thought process here, because, like, we live on this planet, we deserve to be here, so we are allowed to use this underground water. The question is not, should we use this? Because if we don't pull on this, it's just going to sit down there and do nothing. So the question is not, should we use this? It's more of like we need to watch how quickly we're using it. Okay, because we're relying on this aquifer a lot. 90% of the water drawn out of it is directly used to irrigate the crops. And you're going to see in your assignment today how much of an economic, stimulus this is for, like that's where we grow all of our crops. That's where, we grow all of the things that we sell. So this is a very economically viable thing that we've got going on here. However, if we continue to use it at the rate we're using it, it's going to go away very quickly, and it's going to leave a big hole, not only in our economy, but in our food supply. So, I mean, again, this is where we grow all of our food at. And honestly, that right there is directly why we can grow our food there, is because there's so much underground water to be had. So, the assignment that goes with this is the Ogallala Aquifer worksheet thingy. I'll come back here in a couple of days probably to talk about irrigation, pest control, and I think we need to do a little bit more on aquaculture, just kind of sweep it all up and get ready for our test, which is coming up. So I will see you guys later.